This is the second video for Chapter 2 for homework for Statistics 252. And this next problem, again, you're given some data. This was weights of some male teenagers, and it's also, the data's in the textbook. I'd like you to organize it into 6 classes of width 20, start with 120. So the lowest point on each class would be 120, 140, 160, 180, etc. And that's what I mean by state the intervals correctly. You're not going from 120, let me write a little something here on the classes. So you're going to start with 120, and the width is going to be 20, so the next one is 140. So where is this one going to go? 139. Okay, this is what it doesn't do. You don't go 120 to 140. Okay, don't do that. You do like this. And this is going to be 160, so this will be 159. And your class is going to look like that. Make your tallies based on that data. Compute the midpoint. Right? Then get your frequency, relative frequency, and percent. You know how to all do that. And then the cumulative frequency. Okay, so let's do a little bit of this. So here's the data. And of course you have a little chart here to fill in. And you're given what to do. So you know what the classes are going to look like. Here's 120. Their width. Oh, sorry. Let me erase that and start over. Okay, the classes. Yeah, no, that was right. They started at 120, and they were width 20. Right, that worked. 120, 140, 160, 180. Okay. 200. Remember, this only goes to 139. When you compute the midpoint, it doesn't have to be a fraction. You can go ahead and compute the midpoint between these two easy enough. I get a midpoint of, say, 130. This would be 150. And compute the midpoints. Then for the tally, you go again and scan the data and put your hash marks here. Remembering where boundaries go, and then just keep going along here like this, and then you get a frequency. So I'm just going to make up some numbers for the frequency because this is just a demonstration. So you had 4 here, 26, and I've changed this data set. How many do I have here? Okay, total of 30. No, it's 36. No, it's 30. Wait a minute, 1, 2, 3, 4, 5. Okay, fine. Okay. As long as I'm discussing various things, I could make these videos over and over, and I try to make them so there aren't too many errors. But if I made them so they were just perfect with no errors, you wouldn't pay any attention to it, first of all, because it'd be too boring. And second, it's important when you're at distance, you don't see the teacher standing up in front of you making errors and correcting them. Recovering from errors is more important than not making them. So if you see somebody does something wrong, go back, check it, do it again. For people who are very timid about math, they say, oh, everybody makes mistakes, and they just go back and work through it again, and it's not a big deal. So that's why I don't go back and correct all the errors. Okay, say you put all your frequencies here, and again, this is just an example. These aren't the exact ones from this data, and the data in homework is slightly different. You put your tally marks, you turn the tally marks into numbers, and that add them up. Then to get the relative frequency, you take each frequency and divide by that total, in this case 30. 2 divided by 30. And then you get a percent, decimal and a percent. You do that with your calculator, or if you can see what it is, you can do it by hand. Once you have them up, let's get a few numbers here. Okay, so I added some numbers, again, fictitious numbers. This is just an example. It's, you know, the arithmetic's so easy, it doesn't really matter. Alright, so you've got your frequency, you take your, and you add them all up and you get a total. You can count them up here and find your total, but the numbers you add up here had better be equal to the total, or something wrong happened in your tally or your count. To find the relative frequency, you take this frequency and you divide by the total number, in this case 30, then you get a fraction or decimal, and then you can get a percent, in this case 13.3%. And you go down this whole list and you fill all these in. This should add up to 100%, or when you look at the decimal, it should add up to 1. You don't do anything with that number, it's just a check. To find the cumulative relative frequency, you start at the lowest frequency and you put that here. Okay. Then when you go to the next one, you add it up. Add what happens before here, so I've got 19.9. Then this one was 40%, so I add a 40 in here. I get a 59.9. Now I'm adding a 20, and I get a 79.9. So what I'm doing is adding up. This cumulative relative frequency is states that in this case 79.9% of the scores were at this level or below. It gives the standing as you go up through your classes. And the last number here, you never add this up, it doesn't have any meaning, but the last number that goes with our last class, in this case our last class would be 200, would be 220. Okay, this number is 100% because 100% of the people had this value or less. So these numbers are just adding this to this, then you get a sum, add this one in, add this one in, add this one in, and your total will be 100. Not your total, your final number will be 100 because it's the total of all those frequencies. Relative frequency tells you where you stand, where this number stands in relationship to the others. 13.3% of the numbers were between 120 and 139. 20% were between 140 and 159. No. This should have been 180 and 199. Okay, so that says what's the percentage in this range. The cumulative frequency, cumulative meaning add up, tells you how many, what percentage were at this level or below. And then you graph it. You graph these, the frequency, that's what you graph for the histogram. Right? For the relative frequency and the relative cumulative frequency, use those midpoints and draw a polygon. That means just a straight line between those points. And there's graph paper given for that too. So for the classes and everything that you work up for those weights, you can draw on this graph your, get the pen here, you can, well, I'll get a line, you can draw your frequency as the histograms, oops, then the relative frequency, let me change color here, so the relative frequency will be a polygon, and you go to the midpoints, oops, I need a pen, so you go to the midpoints like this, however it looks, and then you connect these up. There's your frequency polygon, and it's going to go up and down. Now the cumulative frequency polygon will start here, but then it doesn't just go to that, it goes up here, it would be something like this, and end at 100%. So this would be the cumulative frequency polygon, and then I use that for frequency. Okay, this would just be the frequency, the relative frequency. Wait a minute, I did that wrong. Well, I didn't finish the others. It's going to go on the top of your histogram, and here are the frequencies itself as a histogram. So this would be your relative frequencies. These are your percentages. This is just the frequency, and here would be the cumulative frequency. It would be a graph like this. You can see one similar to this in the textbook too. And this problem, instead of having numbers, you're going to use categorical data. These are qualitative variables, and this is data for how people get their news by the newspaper, television, radio, or internet. And so you're doing the same thing that you did before. You've got to find the tally, you've got to find, and the frequency. Well, the relative frequency, it doesn't say that here, I should add that. And then you're going to draw a bar graph. Remember, a bar graph looks like a histogram, but there's spaces between the bars, and it can be vertical, like a histogram, or it can be horizontal. So I would like you to make a horizontal bar graph. And now you can't, you aren't going to make classes before because you have the numbers, you're making the classes, 0 to 200, 200 to 400, like that. And the variables themselves, because they were quantitative, or you could organize. Here you can't organize in T, R, I. You could do it alphabetically maybe, but you there's really no innate organization to them, but you can organize them by the maximum frequency to the least frequency. So you're using the count to organize them. So here's the data. So the categories look like this. Be an in, say internet. It doesn't matter what order you put them in, radio and television, and then go ahead and use your pen and make your tally marks. I said don't use tally marks, but go ahead and use tally marks. It works better, and that's actually your frequency. So here's your count. I use tally marks, even though I said not to. Okay, so for newspaper, you've got your counts in 1 in, 2, 3, 4. Actually, it's pretty easy to scan the data when you have something like this instead of having to do it, because it's do the tally marks. So do it either way you want, but at any rate, get the count. So it looks like there's 8 for newspaper. Then you'll have your total down here, which you can find from up here. 5 rows, and the number times the number of columns times 10. There's 50 right there. So all your tally marks should add up to 50. To find the relative frequency, take the count or the frequency, divide by 50, and then reduce that using your calculator. So basically you're doing the same thing you did before, but instead of making these classes that are intervals, you just list the categories, then you list the counts and the frequency, then from that you can find your relative frequencies. And on this screen you'll have the graph started for you. Here you've got your news source preference, and then you organize these as bars, and the bars they can be equal width, but they'll have a little room before them. In fact, if newspaper is the most, and then internet, radio, television, however it comes out, then this would have the longest bar. Maybe I'll do it with a line. And then this would have the next longest, and then this one would be the next longest. Of course, you're going to use a ruler, so these are going to look nice, and then this one. So the way the lettering is over here is not alphabetical or in any particular order. It depends on which one has the largest count. You put that one in the top, and then you go down, remembering there can be spaces. There are spaces between a bar graph. This is a horizontal bar graph. You could have also done it vertically, but for variety we'll do it horizontally. And the next one is just a frequency polygons, but you can have more than one frequency polygon on the same graph. And there's going to be one for each national park, and the data is given to you. But in this case, I want you to be sure to label and number your vertical and horizontal axis yourself. Otherwise, in the other graphs I did it for you. Here I want you to do it yourself. And as it says right here, the grade will be at 0 if there is not a vertical axis labeled appropriately or horizontal axis with appropriate labels, and if the polygons are not labeled with the park name. Sounds kind of, I don't know, maybe a little silly, but if you know, to do the graph, especially in something like statistics, you're trying to make a communication, and if you don't make the notation on it properly, well, it's pretty much useless. Actually, I used to work in a place where certain individuals from other countries would contribute to various conferences, and they would write up some results, and then they would show their data, and the data did not have any labels on the graphs, so you had no idea what it really was, and that was part of their way of not sharing. So here's the data, and this is actually the data as it appears in the homework. I'm not asking you to find frequencies or relative frequencies. Instead, I just want you to be able to plot the data, sort of organize it, plot it, and put 4 of these polygons on the same graph. And these are pretty big numbers, and so your axis on the vertical axis doesn't look so good if you use great big numbers. Who can read them? Instead, you can use the numbers in the millions. This number, it's about 1.3 million. This number is about 3.1 million. So you can label your axes in the millions. The largest million here, of course, is 3.3 million, so you might want to go to 4 million. And so your vertical axis would start at 4. You could have a 3 or 3.5, 2, 2.5, and then go all the way down to 1. Well, obviously that was a big jump, and then I might go all the way to 0. There's your 1. Okay. And then on the horizontal axis, you can do the year. There are your 4 years right there, 2005. And that, of course, does not start at 0. You might do a little like that to show that it doesn't. 2006, 2007, and this would be 2008. So when you do these polygons, you'll have a dot, 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 and dot, and that will be for some national park, which you will label. Another national park, you can do it in a different color, might have visitors that look like this, and so then you will connect those straight lines between the dots, and then label that. And there'll be 4 of them on the same graph. So this is actually just a little exercise in proper graphing. And rounding the numbers in here for the axis label here, you can say visitors, park visitors, and then putting a comma in millions. You've seen that before. And down here, these are years. Not really important to label that, but you could label that. This has to be labeled, and then you say in millions, and then you just write the numbers like this, and you don't have to write something with a whole bunch of big zeros. Now this homework ends with writing the 5 requirements for classes for group data. I think we kind of went over those before. They have to be exhaustive, continuous. There should be a certain moderate number of the classes they have to be equal with. So you can look in the book or in the written notes that I put on the on Blackboard to find requirements for classes. And then there's 2 ways that graphs can be misleading. One way is that if the vertical axis doesn't go all the way to 0, if it goes down here and say this is your data, but on the vertical axis this might be, say, oops, didn't pick up the pen, 3 million, then this is 4 million, and some data is presented here, for example maybe a histogram. But that looks like there's a big difference between these 4 cases. If you plot it all the way to 0, you would see they're very similar. So not having the vertical axis go all the way to 0 is one way to mislead the differences between the data. This exaggerates the differences. The other way graphs can be misleading is if instead of having dots, so here's the data, so here's the net worth of some banks in billions. And this does go all the way to 0, but instead of showing, and this is over January, February, and March, say, look like that. Okay, instead of showing a dot, there's some figure showing, like, for example, a $sign. And the $sign looks small here, and then $sign looks bigger here, and the $sign looks immense here. It's like using clip arts instead of dots. Now, you can see that the change here is from 1 to 2 to 2.5, or something like that, 1 to 1.75 to 2. But the size of these misleads you into thinking this is enormously bigger when it isn't. So using some kind of caricatures, clip art, some kind of drawings, instead of just a dot or an X or a square, to show the data points, that can be misleading because the change in the size of this clip art thing does not reflect the actual difference. All that counts is this relative location. Those are 2 ways that graphs are misleading. So this is the end of the homework for Chapter 2 for statistics.